Hi, I am Sam Guan with NX Product Marketing. Today, I'll share with you some of the new functionality that was released in NX 2412 that is made available to our customers back in December of 2024. Key improvements are NX will retain constraints as users restructure components within assembly. And when they use copy and paste components, NX will include associative constraints. New capabilities constraints are joints and couplers for joints, both internal and external references. NX will either automatically update the external constraints to reflect a new position within assembly, or provide an automated way to resolve these constraints as they're external to the paste function. Here we have a gearbox assembly, and a gearbox already has a fixed position. I will now add a hinge joint between the gear and the gearbox. Let's add one more instance of this gear component, a new hinge that this will show the external joint references need to be satisfied. As I copy and paste the gear, the constraint dialog will appear, and we see that unresolved hinge joint shows in list. Using the dynamic dialog, let's define the vector and the center point of the hole for the gear hinge to rotate. From the Assembly Navigator constraint listing, these constraints are resolved. Next, I will review the internal joint and the coupler support. Having two hinge joints from these two gears, let's add a gear joint coupler. In the gear joint, selecting the first and the second, being the same size, the ratio will remain at 1. Editing the angle offset correctly position these gears to each other. As we move or rotate one gear, you'll see the relative motion to the other. Let's copy all three of these components into a different file. Two hinge joints and a gear coupler are copied and pasted into the new model, so all these automatically comes across. To see the relative motion of these two gears again, I just need to fix the position of the gearbox, then NX will resolve the relative motion of the gears properly. Finally, I'm going to show a mixed case where we have external joints plus an internal coupler. I'm going to add these gears to another part with a different gearbox. As we can see in this model, currently there are no constraints here. So the hinge joint have become external now. So we get the opportunity to resolve them with a constraint dialog. The gear coupler remains internal to these two gears, so it will be copied automatically with the components. Update correctly when hinge joints are resolved. You will see a different approach to solve these constraints using a rectangular offset due to the thicker base or boss for the mounting of these gears. Again, select a vector and the offset position to satisfy the point locating requirement. The auto progress in a similar fashion for the second gear. Last portion of this, just simply updating the offset to the correct angle value. Once that is done, we see that these gears can once again move in relative to one another. Here is another demonstration that shows how NX preserves constraints. An ability to copy associative constraints as components are dragged and dropped into a different location within assembly. Here we have a top-level gearbox assembly, and underneath we see the APU gearbox gear assembly, and there are constraints defined already. The component of transfer gear input, there are several constraints. Two are aligned, and the other is distance. All are at the APU gearbox gear assembly level. In this case, transfer gear input is dragged into the top level, and this component, as you see, the constraints are automatically maintained and preserved at the top level assembly. In the previous release, users would have received the NX Resolve Constraint dialog to redefine any external constraints. The new enhancement, both align and distance constraints are preserved. In addition, the APU gearbox gear assembly name is shown within this constraint to assist identification. This listing of reference constraint will improve the productivity for the users and simplify the workflow for the users as they are restructured their assembly. This concludes my presentation today. Thank you for your time.